Good morning, all of you. In this session, I am going to explain about different types of support reactions. In this session, I will explain about these three topics. Okay. This is a horizontal plane diagram. This is a inclined plane diagram. This is a string problem. Okay. I will discuss in this session. From the Newton's third law of motion, we know that to every action there is equal and opposite reaction. Okay, so action, reaction, it is very important for our engineering mechanics subject. Okay, here from Newton's third law of motion. Okay, we know that to every action there is equal and opposite reaction. Okay, opposite reaction. Okay, for every action there is equal and opposite reaction. Okay, hence reaction is always equal and opposite to the action. Okay, equal and opposite to the action. Okay, so this is the main fundamental. And here in our mechanics subject, we consider capital R. Capital R or reaction force. Okay, capital R represents reaction force, normal reaction force. Okay, capital W indicates self weight of a body. Okay, self weight of a body in newtons. Okay, reaction force also in newtons. Now let's consider a horizontal plane. Let's consider a horizontal, smooth or rough plane. Okay, so this is a fixed plane. Okay, fixed or a rigid plane. Okay, now I am considering a roller, circular roller of weight W. Okay, W is the self weight of this roller. Okay, now I am placing this roller on this horizontal plane. Okay, then the self weight of this roller acts vertically downwards. Okay, this self weight exerts a force on this horizontal plane. Okay, now you can observe, yeah, this self weight always acts vertically downwards. Okay, please remember, self weight of the body always acts vertically downwards. Okay, like this. Okay, so self weight also a force. Okay, vector quantity. So you have to represent this self weight as like this. Okay, so according to the Newton's law, okay, self weight of the body always acts vertically downwards due to gravitational force. Okay, so self weight, you have to consider self weight as a vertical force. Okay, vertically downward force. Now due to this self weight, okay, force exerted on the horizontal plane. Okay, here due to acting of this self weight, a normal reaction, opposite reaction force will develop at point of contact. Yeah, this point is the point of contact between the horizontal surface and roller surface. Okay, this is a common contact point. Okay, so that here the self weight of the body acts vertically downwards, and at the same place the perpendicular or normal reaction force acts vertically upwards. Okay, so this normal reaction always makes 90 degrees with respect to the support. It is very important. You have to draw a normal reaction force. Okay, you have to draw a normal reaction force with respect to the given surface, given support. Okay, so this is a support. Here you have to consider this horizontal plane as a support. Okay, now you have to consider reaction force perpendicular to the support. Okay, always you have to consider perpendicular or normal reaction. Okay, now for solving the problem you have to consider these forces as like this. Here you have to consider a horizontal axis, that is x-axis or reference axis. Now you have to consider this self weight as it is. Okay, and then after you have to consider this reaction force vertical upwards as it is. Okay, now this is the free body diagram for this diagram, free body diagram. Okay, in free body diagram indicates only forces acting on the body. Okay, this is a opposite reaction force, this is the action of the body. Okay, here we have to consider self weight as action and the reaction force r capital R is the reaction. Okay, opposite reaction. Okay, so this is the one simple case. Now there is another case. Now in same way, if you are placing a rectangular block of weight W, placing on a horizontal plane, then the same the self weight of the block also acts vertically downwards. Okay, and then after you have to consider a opposite reaction force capital R perpendicular to the support. Okay, this horizontal plane is a support. Okay, so you have to draw a 90 degrees normal reaction line with respect to the support. Okay, now for solving the problems you have to consider this diagram into forces diagram like this. Okay, this is the free body diagram. For any type of bodies you have to consider like this for horizontal supports. Okay, now coming to the another example. Now this is a vertical support. This is a vertical support. If you are placing a object on this vertical support, okay, then the self weight of this block you have to consider vertically downwards. Okay, the self weight of the block always act vertically downwards. Okay, the self weight of the block always acts vertically downwards like this. And here this surface is the common contact area. So at the point of contact you have to consider normal reaction, perpendicular normal reaction like this. Okay, at the supports you have to consider perpendicular reaction force, that is a normal reaction force. Okay, so this normal reaction force makes an angle 90 degrees with respect to the given support. Here this vertical surface is a support. Okay, so you have to consider perpendicular reaction force with respect to the support. Okay, now these two are the forces. Okay, W is the action and the R is the reaction. Okay, so these are the forces diagram. Okay, this is the given free body diagram. Okay, for solving the problems, you have to consider force and reaction force like this for this type of problems. Okay. Here you can observe this. I consider this vertical surface as a vertical axis. Okay. And this reaction force makes an angle 90 degrees with respect to the vertical axis. Okay, like this. Okay, this is a horizontal force. This is a vertical force. Okay. Now coming to the another type, it is very important for our mechanics subject. Okay, this is a inclined plane. This inclined plane makes an angle theta with respect to the horizontal axis. Okay, here you can observe this is a inclined rigid plane. Okay, this inclined plane makes an angle theta with respect to the horizontal. Okay, so this is the, here theta is called angle of repose. Okay, or angle of inclination. Okay, now we are placing a object on the inclined plane. Okay, now you have to observe action and reaction. How to consider action and reaction? From Newton's third law, you have to consider self weight. Self weight vertically downwards. Okay, already we know that self weight of any body acts vertically downwards. Okay, self weight of a body always acts vertically downwards. Okay, like this. And the reaction force, you have to consider reaction force perpendicular to the support. Okay, this is a inclined support, so you have to draw a perpendicular line to the support. Okay, so this is the reaction force. This reaction force makes an angle 90 degrees with respect to the inclined support. Okay, you can observe this reaction force makes an angle 90 degrees with respect to the inclined support. Okay, the line of action of reaction force always depends upon the angle of inclination of the plane. Okay, for horizontal supports you have to consider vertical reaction. For vertical supports you have to consider horizontal reaction. For inclined supports you have to consider inclined reaction. Okay, so here now for solving the problems you have to consider this vertical force W self weight as a vertical force, and this reaction force makes an angle theta. How to determine the angle of inclination of the reaction force with respect to the horizontal? Here I consider a horizontal axis here. Okay, I want to determine the angle of inclination of the reaction force with respect to this horizontal line. Okay, here I consider this is a x-axis, this is a y-axis. Okay, I want to determine the angle of inclination of this reaction force with respect to the x-axis or y-axis. Okay, here you can observe this is a horizontal line. Okay, this is a horizontal line. This horizontal line, this is a inclined plane. This inclined plane makes an angle theta with respect to the horizontal. Okay, so here I consider this horizontal line. This line and this line both are parallel. Okay, this dotted line and this bottom horizontal line both are parallel to each other. So this horizontal line makes an angle theta with respect to the inclined plane. In same way, this theta angle makes same with respect to the horizontal and inclined plane as it is. Okay. So this is the inclination of the inclined plane with respect to the horizontal line. Okay. Now already we know that the total angle between the this inclined plane to the reaction force is 90 degrees plus 90. Okay. So here from this side you can observe 90 degrees, and also from this side also it makes angle 90 degrees. Okay. So 90 plus 90, 180 degrees total angle. So in 90 degrees already we got theta angle, and the remaining angle, this remaining angle is 90 minus theta. Okay. So the angle between this horizontal line and the reaction force is 90 minus theta. Okay. So theta plus 90 minus theta plus 90. Total angle is 180 degrees. Okay. So the angle between horizontal line and the reaction force is 90 minus theta. Okay. So here theta is the angle of inclination of the inclined plane with respect to the horizontal. Okay. Theta is the angle of inclination of the inclined plane. Okay. With respect to horizontal. Now, in similar way, if you want to determine the angle of inclination with respect to y-axis, then the angle is theta. Okay. So you can take any angle theta or 90 minus theta for solving the problems. Okay. Please note down this diagram. It is very important for engineering mechanics subject. Okay. So this is the given diagram. I converted this given diagram into forces diagram. Okay. Here the self weight of the object you have to consider vertically downwards. Always you have to consider self weight as vertically downward force. Okay. And you have to draw a normal reaction force with respect to the given support. Here the given support is inclined plane. Okay. You have to draw a 90 degrees reaction force with respect to the given support. Okay. This is the final forces diagram. Okay. For solving the problems, we have to consider this force diagram. Okay. Now, another important topic, that is forces or reaction forces in cables, strings, wires, ropes, like this. Okay. How to indicate internal forces in cables, strings, wires, ropes. Okay. Consider a block of weight W. Consider a block of weight W which is suspended from a fixed support. Here you can observe this is a fixed support. Okay. You have to consider a block of weight W, which is this block is supported by a means of a string. Okay, as shown here. Okay, consider a block of weight W. Okay, which is suspended from a fixed support by means of a string. Okay, by means of a string. This string is assumed to be lightweight. Okay, this string is assumed to be lightweight. That is, it's the mass of this string is negligible. Okay, the mass of this string is negligible compared to that of this block. Okay, and this string is inextensible. Okay, that means its length increases by a negligible amount of negligible amount. Okay, its length increase by a negligible amount because of the weight of the block. Okay, now here capital W is the self weight of the body, and here capital T or capital R is the tension or reaction force in the string. Okay, now how to convert this given diagram into forces diagram. Okay, here you can observe this is a given body. Okay, given body or given object, the self weight of the body uh, acts always vertically downwards. Okay, you can observe. Okay, so you have to consider this self weight W as a vertical force. Okay, vertically downward force W. By acting this vertical force in downward, then a considerable amount of tensile forces developed in the string. Opposite tensile forces developed in the string. Okay, so here this is the developed tensile forces in the string. You have to consider this in this tension or reaction force as capital T or S or capital R. Okay, so here this is the internal reaction force. Okay, T is the internal reaction force developed in the string. Okay, so here capital W is the action. Okay, T tension is the reaction. Okay, so in this situation you have to consider vertical downward force as a self weight and vertical opposite tensile force capital T. Okay, T is the tensile or tension or reaction force developed in the string. Okay, this is the force diagram. Okay, here is another example. Consider a block of weight W which is suspended from a fixed support by means of a string, by means of two strings as shown in here. Okay, here W is the self weight of the body. Okay, now how to convert this given diagram into forces diagram. Here you have to consider this weight as a vertical reaction force. Self weight of the body always acts vertically downwards. Okay, so due to the loading, due to the action of this force, okay, opposite tensile forces developed in the each string. Here T1 is the tensile force developed in the string 1. Okay, and T2 is the another tensile force developed in the string 2. Okay, so here we are using two strings, okay, for supporting the load. Okay, that's why due to the action of this load, okay, tensile forces developed in each string. Okay, T1, T2 are the individual tensile forces. Okay, the value of T1, T2 mainly depends upon the angle of inclination. Okay, angle of inclination with respect to the supports. Okay, so for solving the problems, you have to consider this diagram as vertical load W and the tension T1 and tension 2. Okay, you have to consider this given diagram into force diagram. Okay, this is the final free body diagram for this type of problems. Okay, here W is the action and T1 T2 is the reaction. Okay, by using these fundamentals, you have to solve this problem. This is a simple example problem. Okay, a block of weight 100 newtons is suspended from the ceiling by a string as shown in figure. Find the tension in the string. Okay, a block of weight 100 newtons. Here the self weight of the body is given, that is 100 newtons. Self weight of the body is suspended from the ceiling by a string as shown in figure. Okay. Okay, here the 100 newtons block is suspended from the ceiling. Okay, by using a string, vertical string. Okay, now you have to find out a tension in the string. Okay, already we discussed previous. Okay, so already we know that the self weight of the body acts always vertically downwards. Okay, this is the self weight of the body. Okay, the self weight of the body always acts vertically downwards. Okay, by acting this load, the opposite tensile forces developed in the string. Opposite, you have to consider opposite direction. Okay, so this is the opposite reaction force developed in the string. Okay, here I consider capital T as the tensile force in the string. Okay, now you have to consider a free body diagram like this. Okay, this is the free body diagram. Now already we know that sum of all vertical forces. Here these two forces are lies on vertical plane. That means y forces, y components. So you have to add these two forces for determining the unknown value capital T. Here capital T is the unknown force. Okay, so W is the given force. Sum of all vertical forces, summation of y equal to 0. Okay, now you have to consider upward direction as positive sign, downward direction as minus sign. So plus T minus W equal to 0. Okay, now T equal to W. So the value of tension T equal to 100 newtons. So the tension developed in the string also equal to the self weight of the block 100 newtons. Okay, this is the answer for this problem. In similar way, you have to solve another problem. A circular roller of weight 100 newtons and radius BC equal to 10 centimeters hangs by a tie rod AB equal to 20 centimeters and rests against a smooth vertical wall at C as shown in figure. Determine the force in the tie rod AB and support reaction force at C. Okay, this is the given diagram. Okay, a circular roller of weight 100 newtons. Okay, and radius BC equal to 10 centimeters. Okay, hangs by a tie rod, supported by a tie rod AB. The length of tie rod AB equal to 20 centimeters. Okay, this roller rests against a smooth vertical wall. Okay, at point C. Okay, point C is the common contact point. Okay, common contact point between the roller surface and vertical support. Okay, so in this question you have to determine the value of force induced in the rod. That is you have to consider like tension in the rod AB. And also you have to determine the support reaction force at point C. Okay. Now first we have to convert this given diagram into forces diagram. Okay. So this is the given diagram. Already we know that the self weight of the body acts vertically downwards. So I am drawing the vertical force. Okay, this vertical force indicates self weight. Okay, self weight always acts vertically downwards. Okay, this is the magnitude of the self weight. Okay, now already we know that the reaction force acts acts perpendicular to the support. Okay, so at the point of contact you have to consider reaction force. Okay, at point C is the common contact point, so you have to consider a reaction force at this point, and also you have to consider a reaction force perpendicular to the support. Here the support is vertical, so you have to consider horizontal reaction. Okay, so this reaction force makes an angle 90 degrees with respect to the given support. Okay, this is the reaction force at point C, and this is the self weight. Okay, now due to the acting of this load, okay, a tensile forces, a tensile force is developed in the tie rod. Okay, so opposite you have to consider opposite internal force, internal reaction force. Okay, so this is the tensile force developed in the tie rod. Okay, so you have to consider a opposite reaction force. Okay, this is the action. W equal 100 newtons is action. It acts vertical downwards. So you have to consider opposite direction for determining the internal force developed in the rod. Okay, so from force diagram you have to draw free body diagram. Okay, vertical force W equal 100 newtons and reaction force R equal R. The value of R you have to find out, and this is the FAB, force in the tie rod AB. Okay, it makes an angle theta with respect to the horizontal. Okay, now from the given data you have to find out the value of theta. Okay, already we know that the radius of BC, the value of BC equal to 10 centimeters and the value of AB equal to 20 centimeters. So you have to consider a triangle ABC for determining the value of theta. Okay, here the length of AB equal to 20 centimeters and the length of BC equal to radius equal to 10 centimeters. Okay, now you have to consider a theta. You have to consider a angle theta here. Okay, so cos theta equal to adjacent side by hypotenuse, so 10 by 20. Okay, from this equation the angle theta equal to 60 degrees. Okay, so theta equal to 60 degrees. This is the free body diagram. So now you have to convert this free body diagram into vertical and horizontal forces diagram. Okay, so I consider this vertical force as it is and horizontal force also as it is. Okay, now you have to convert this inclined force into horizontal and vertical force. Okay, this inclined force FAB lies in the second quadrant. Okay, and it makes an angle 60 degrees with respect to the x-axis. Now you have to convert this inclined force into horizontal and vertical force. Okay, here this is the horizontal force, this is a vertical force. F cos theta, F sin theta. Okay, for adjacent sides you have to consider cos theta, for opposite sides you have to consider sin theta. Now I am considering these two forces here. Now this is the vertical force. This vertical force acts vertical upward. F sin 60. Okay. Now you have to consider this horizontal force on x-axis. Okay, like this. Okay, so F cos 60. This force acts towards left. Okay, now these two are the horizontal forces. These two are the vertical forces. Okay, already we know that for determining the unknown values, yeah, you have to use sum of all horizontal forces equal to 0, sum of all vertical forces equal to 0 equations. From this equation, sum of all horizontal forces equal to 0. Okay, by adding these two horizontal forces, you can get the value of unknown force R. Okay, Fx equal to capital R in right side direction, so plus R, and this one is minus F cos 60. Okay, equal to 0. From this equation, capital R equal to F cos 60. This is the one equation number 1. Okay, now sum of all vertical forces Fy equal to 0. By adding these two vertical forces, you can get the value of force FAB. Okay, F sin 60 acts vertical upwards, so you have to consider positive sign. Okay, you have to consider minus sign for downward direction, so minus 100. So F sin 60 minus 100 equal to 0. F sin 60 equal to 100. Now F equal to 100 by sin 60. 100 by sin 60 equal to 115.47 newtons. This is the force induced in the tie rod. Okay, force induced in the tie rod AB equal to 115.47 newtons. Okay, now substitute this force F value in this equation. You can get the value of reaction force. Okay, reaction force at C equal to R equal to F cos 60. Okay, substitute value of F in this equation. Finally, you get value of reaction force 57.73 newtons is the magnitude of a reaction force R. Okay, this is the final answer. Okay, so this is the procedure for determining the unknown values. Okay, in next class I will explain more problems on this type. Okay.